Okay, in part C we're given a function f of theta. We're asked to find f double prime of theta. So f double prime means we need to find the second derivative. So once we find the derivative, we need to do it again. If you substitute a value for theta into this function, the last thing you're going to do is multiply theta times tangent of 3 theta. That means I'm going to have to use the product rule here. So f prime of theta is, I take the derivative of the first factor with respect to theta times the second factor plus theta times the derivative with respect to theta of the second factor. The derivative of theta with respect to theta is 1. Now I need to figure out how to take the derivative of the tangent of 3 theta. Well, once again I look. The variable of differentiation here is theta. What's inside the trig function is 3 theta. So that means I have to use chain rule on this. I take the derivative of the tangent of something with respect to theta. That's secant squared of that thing times the derivative of that thing with respect to theta. So this is secant squared of 3 theta times the derivative with respect to theta of 3 theta. So I get the tangent of 3 theta plus the derivative with respect to theta of 3 theta is just 3. So I have a 3 I can migrate out front. So 3 theta secant squared 3 theta. That gives us our first derivative. Okay, there's our first derivative. Now we're going for the second derivative. If you substitute something in for theta, the last thing you would do is add these two quantities together. So that's the first rule I have to apply, is the sum rule. So the sum rule says that the derivative of the sum of two functions is the sum of the derivatives. The derivative with respect to theta of the tangent of 3 theta, we just did that. It's secant squared of 3 theta times the derivative of 3 theta. And we got 3 secant squared 3 theta. So that was the chain rule there. Looking at what I have over here, if I plugged in a value for theta, the last thing I would do is multiply by that 3. So I'm going to apply that derivative rule first. The constant multiple rule says I can bring the 3 out front. Now, looking inside at this derivative, I've got theta times secant squared of 3 theta. That multiplication would be the last thing I do, which means I need to use the product rule. So I'm going to give myself some more room here. I have 3 secant squared 3 theta plus 3 times the derivative of theta with respect to theta times secant squared of 3 theta plus theta times the derivative with respect to theta secant squared 3 theta. So I have 3 secant squared 3 theta plus 3 times the derivative of theta with respect to theta is 1 times secant squared 3 theta plus theta times the derivative of secant squared 3 theta. So I'm going to go off here on the side and look at that problem. Looking at the derivative with respect to theta of secant squared 3 theta. Well, I'm going to rewrite that power as I'm used to doing. It's secant of 3 theta squared. That tells me the first rule I have to apply is the power rule. if you take the derivative of something squared, it's 2 times that thing's times its derivative. Okay, so it's 2 times that thing times its derivative. Just get this out of the way here. So this is equal to 3 secant squared 3 theta plus 3 times secant squared 3 theta. I've got a 2 theta secant 3 theta. From combining these first two factors, now I need to figure out the derivative of the secant of 3 theta. Well, since the variable of differentiation theta is different than what's inside the secant function, I need to use my chain rule. So the derivative with respect to theta of the secant of something is the secant of that thing times the tangent of that thing times its derivative. So I've got the secant of 3 theta times the tangent of 3 theta times the derivative with respect to theta of 3 theta. So this entire thing here is the derivative of the secant of 3 theta. So I get 3 secant squared 3 theta plus, I'm going to go ahead and simplify what I got in here. I've got 3 times secant squared 3 theta plus, what am I going to get in here? The derivative of 3 theta with respect to theta, that's going to be 3. So I've got 3 times 2 theta, that's 6 theta. Secant times secant is secant squared 3 theta times tangent 3 theta, like so. And so we're almost there. Alright, so the calculus is done. Now it's just time for some algebra cleanup. I have 3 secant squared 3 theta plus, I'm going to distribute the 3 through here. I get another 3 secant squared 3 theta, and then I get an 18 theta secant squared 3 theta tangent 3 theta. I add these together, I get 6 secant squared 3 theta plus 18 theta secant squared 3 theta tangent 3 theta. Now with what we're going to do with this in Chapter 3, we would notice that we can factor a 6 secant squared 3 theta out of each term if we were solving this for some reason equal to 0. But as far as taking the derivative and simplifying, this is as good as we're going to leave it. That'll do it for C.